An athlete takes part in a race. His performance is shown on the speed time graph. So here we are having the speed of the athlete. Then here we are having the time taken for the athlete to run this race. Okay. So we have point A, point B, point C, and point D. Now the question is saying, use the graph to describe the motion of the athlete between Roman numeral number 1, A and B. What was happening from A up to B? So from A up to B, the athlete was accelerating. So we are going to say the athlete was moving with uniformly acceleration, or the athlete was accelerating. Then Roman numeral number 2, B and C. What was happening from B up to C? So from B up to C, the athlete was moving with zero acceleration, or we can say constant speed. Meaning if an object is moving with constant speed, it is going to have zero acceleration. Okay? Then as for Roman numeral number 3, C and D, this point here up to D, what was happening here? The athlete was reducing in speed, or the athlete was decelerating. So those are the answers. As for B, it is saying, calculate the distance traveled between 5 seconds and 20 seconds. So we have 5 seconds starting from this point here, up to where 20 seconds is ending at this point here. So now the area under the graph is equal to the distance traveled by an object. Now what shape is this one here? This shape is called the rectangle. Now the area of the rectangle is equal to length multiplied by breadth. So in this case, the length is this one here and the breadth is this one here. So now what is our length that we have here? So the length, we are going to say 20 minus 5. Then what are we going to have? We are going to have 15. Then multiply by the breadth that we have from this point here up to this point here. What are we having here? We are having 10. So we need to say multiply by 10. Then 15 multiplied by 10, we are going to get 150 meters squared. This one is the area. Then at the end, we are going to say, therefore, distance is equal to 150 meters. Meaning this one is going to be our final answer. Let's see the next question. So the next question is coming from simple machine. And it reads, figure B3.1 shows a ramp being used to lift a box weighing 480 newtons through a distance of 3 meters and a height of 1 meter by applying a force F of 200 newtons. Okay. Question A. State the meaning of the term simple machine. So the simple machine is any device which uses less effort. When I say effort, meaning the force applied. So a simple machine is any device which uses less effort to overcome a big load. Any device that you can apply less effort and it is going to overcome a big load, that one is going to be a simple machine. Okay. So always you are going to find that the force applied, which is the effort, is going to be less than the load or the weight of an object. This one is very, very important. Suppose you have an object weighing about 300 newtons. Just imagine or just guess the force that you are going to apply for you to move this object. Is it going to be greater than 300 or less than 300? It is going to be less than 300, meaning that one is going to be the simple machine. Now, there are terms which are used on this part here. When you say weight, weight is just same as the load. Okay, same as the load. Then when you talk of force applied, this force applied is same as the effort. So effort is just the force applied. So those are the things that you need to know on this part here. Okay, so let's try to look at the next question. So the next question is saying, calculate the mechanical advantage of the ramp shown in figure B3.1. So on this part, you need to know the formula. So mechanical advantage is equal to load over effort. Those things you need to know. Formula. So now, according to the data that we can collect from this question, we can say that the weight that we are having here, meaning the load that we are having here, it is 480 newtons. Then apart from that one, we also have the force applied, which is the effort, E, which is 200 newtons. So let's calculate now the mechanical advantage. So here I'm saying load over effort. So the load that we have here is what? 408 newtons divided by 200 newtons, which is the force applied. So Newton and Newton, they are going to cancel each other. Then here when I divide, I'm going to get 2.4. A mechanical advantage is just the ratio of the load over the force applied, or the effort applied. So in this case here, since it is a ratio, it is not going to have the units. Those things you need to understand them. Then C, it is saying, calculate the efficiency of the ramp. So efficiency is equal to mechanical advantage divided by velocity ratio multiplied by 100%. So now on this part here, do we have the velocity ratio? We don't have the velocity ratio. So now let me just give you the formula for calculating the velocity ratio. So velocity ratio is equal to the distance moved by effort divided by the distance moved by load, or by the load. So let's try to determine the distance moved by the effort divided by the distance moved by the load. Remember, the distance moved by effort is the distance moved by the applied force. Then the distance moved by the load is same as the height. So let's see. So we can say the distance moved by effort here is just going to be equal to this distance here. As you can see here, force F was applied. Now the distance which was covered here is just what? 3 meters. So we are going to say 3 meters here. Then the distance moved by load, meaning the height that we have here, it is what? 1 meter. So the distance moved by the load, which is 1 meter. Okay, so let's just calculate the velocity ratio here. So the velocity ratio, let me just use this part here. Velocity ratio is going to be equal to the distance moved by effort, in this case here it is 3 meters, divided by the distance moved by the load, which is 1 meter. So meter and meter, they are going to cancel each other. When I divide here, I'm going to get 3. Meaning the velocity ratio that we have here is what? It is 3. So by definition, velocity ratio is the distance moved by the effort over the distance moved by the load. That's the definition for the velocity ratio. So now let's calculate now the efficiency. So efficiency is equal to mechanical advantage. In this case here, the mechanical advantage, it is 2.4 divided by the velocity ratio. In this case it is 3 multiplied by 100%. Okay, if we multiply by 100%, what are we going to have? 2.4 divided by 3 multiplied by 100%. We are going to get 80%. Meaning the answer here that we are going to write is going to be what? 80%. Sometimes in an exam they are going to ask you, why is the efficiency less than 100%? The reason being is that it's going to be due to what? The friction. It is just going to be due to the friction.